Hi, everyone. My name is MacLane Wilkison. I am one of the co-founders of NuCypher. NuCypher is a data privacy layer for blockchain and decentralized applications. So we give developers a way to store, share, and manage private data on public blockchains, or more specifically, file systems like IPFS and Swarm. So let's say you're building a medical records application. You want to store patient records on IPFS. By default, everything you store there is public. Anyone can go and download those records, which in the case of a healthcare record isn't great. You need some way to have those be private, confidential, and encrypted. And then you still need some way to share those encrypted records with a valid recipient. So let's say a doctor, hospital, insurance company. And this access control infrastructure is a layer that we provide at NuCypher. So you can think of us almost as like TLS or HTTPS, but for dApps. So before I get into kind of the architecture of what we built and how we built it, maybe go over some of the use cases and maybe spur some ideas for things you guys could potentially build over the next few days, and also kind of simultaneously explain why we think what we're doing at NuCypher is important. So the very obvious one is data file sharing. So let's say you're sharing files, could be medical records, could be anything else, in IPFS or Swarm. We have those files encrypted. Maybe you want to share those files with your friends and family, with their photos, medical records with doctors, healthcare professionals. It could be anything. So you could imagine building like a decentralized end-to-end encrypted Dropbox on top of IPFS and NuCypher. Another very interesting application would be end-to-end encrypted group chats. So even for centralized applications, it's actually very difficult to build end-to-end encryption into group chats. You have things like Signal using double ratchet encryption. Our Proxy Re-encryption technology is also a very elegant solution for this sort of thing. And the reason is that it's very expensive to encrypt. When you have a bunch of people in a chat, you have to basically encrypt every message between every participant. So every time a new person joins, you have to encrypt all the messages for them. Every time they send a message, you have to encrypt that message for each other participant in the chat. And using NuCypher, this actually is much, much easier, performant and simple. You could also imagine building decentralized Netflix or selling content. So you have encrypted content. It could be video streams. It could be photos. It could be a computer program. And that data, or that component is encrypted and only gets decrypted in exchange for payment. So you could have a smart contract that only allows a recipient to decrypt your data if they pay, let's say, 5 ETH to your address. In the way that we typically solve this data confidentiality and integrity and privacy problem in a centralized setting is obviously with things like TLS or encryption in transit. But fundamentally, if you're using Gmail or Dropbox or Google or any of these centralized service providers, even though you have this encryption in flight, you're fundamentally trusting the central service provider with all of your data. And maybe it's fine to trust Google or Dropbox with your data. Maybe they're not a malicious actor, but potentially some of the people that are trying to hack into those service providers would be malicious. And actually, if you extend this to a decentralized setting, you definitely don't want to have your data plain text server-side, because that could be an IPFS node that's sitting in some random guy's basement. So we can't have this sort of same architecture for blockchain and for dApps. So what we've done is we've combined two core technologies, something called Proxy Re-encryption, as well as obviously decentralization via the Ethereum blockchain, to create a decentralized key management service. And I'll kind of go through how we've built that. But to start, I'll explain what Proxy Re-encryption is. So Proxy Re-encryption is a more scalable form of public key encryption. So if you think of public key encryption as being very good for one-to-one communication, let's say I need to share a secret message with any one of you in the audience. I can just encrypt that message with your public key, send it across the network. You can decrypt with your private key. It works perfectly well. But now let's say I want to share that message not just with one of you, but with everyone in this room. I'd have to encrypt n times for each one of you, send it across the network again n times. It just scales very, very poorly. Whereas with Proxy Re-encryption, I can encrypt that data one time under my own key, and then I can delegate and revoke access to arbitrarily as many people as I want. And you could imagine using Proxy Re-encryption as a cryptographic primitive to build a traditional centralized key management service. So you've got a data owner and a potential recipient, as well as some storage layer. So you encrypt your data, upload it to storage. When you want to share that encrypted data with some valid recipient, what you could do is you can create something called a re-encryption key. And this re-encryption key is based off of you, the data owner's, your private key, and the recipient's public key. So a re-encryption key targets some specific public key. You can give this re-encryption key to an untrusted proxy. All this proxy can do is re-encrypt or re-key or transform the encrypted data from being encrypted under your key into being encrypted under the recipient's key. So that data never gets exposed in plain text, so the storage layer or the proxy never actually see the plain text data. The only people who ever have access to that data are the data owner and the delegated recipient. But we've actually taken that a step further, so instead of, for blockchain, instead of having one re-encryption key, we've created a threshold split key proxy re-encryption algorithm that we call Umbral. And we can take that re-encryption key and split it up into many different key shares. You can tune this, so you can require, say, a threshold or a quorum of these key shares to come together in order to re-encrypt data. So you can say, I require 30 of 50 of these key shares, or 2 of 3, very similar to a multi-sig transaction. And only once some threshold number of those key shares have come together, or those nodes have come together, will the data get re-encrypted. So what you do is we split that key up into a bunch of shares, issue those shares out to the nodes in the NuCypher network, and you basically have this entirely trustless key management service. So you're no longer having to trust AWS Cloud HSM, Azure Key Vault, HashiCorp Vault, any of these centralized key management providers. You don't trust us either. You issue the access policy, and it lives on the blockchain and on the NuCypher network. The function of the token is actually for staking, so not for payment. So if you want to be a node in the NuCypher network and earn revenue via fees that users pay to the network, as well as mining rewards, you have to stake the NuCypher token as a security deposit or collateral. So this basically provides an economic incentive for nodes to behave correctly. So if you, as a node, are going offline, or instead of properly re-encrypting, you're just spitting back garbage, anyone can challenge you, slash your stake. So it basically ensures that nodes are doing their job the way they should be. A few other, just a couple sample users for NuCypher, and maybe potentially jog some ideas for you guys. Decentralized data exchanges, data marketplaces. So there's projects like Datum that are aggregating a bunch of different kinds of data. In this case, it's user browsing history, and then giving regular people a way to monetize that data by auctioning it off to advertisers instead of Facebook and Google profiting off of your data. NuCypher is the access control layer for a lot of the decentralized databases like Bluzell and Fluence. Healthcare is also a big one. Obviously, it's this medical record sharing use case. A lot of interesting applications in IoT, as well as transferring digital assets as well. We have 10 ETH bounty for the hackathon, 4 prizes, 2.5 ETH each, 2 prizes for the most innovative use and imaginative use of the NuCypher protocol, and then 2 prizes for the most impressive actual implementation and technical implementation of it. If you want to learn more, join our Discord. All of our development discussions happen there. We also have a specific channel for the hackathon. On our GitHub, we also have a repo. There's a quick start guide for this weekend. And we are all here for the most part this weekend, so come and grab us, and we'll have a workshop tomorrow morning at 9 a.m. and look forward to seeing you all there. Thanks very much.